I'm going to speak in English, okay? So 学生们在这个 session 里面，我会用英语来解释给你们听，关于这个basic concepts of programming, okay? So 我们有2个 session， 第一个 session 是在8点半早上到10点 ，okay？ 我们会讲关于 overview of computers, introduction to programming, basic concept of programming。所以在这个 basic concept programming， 我们会了解关于这2个很重要的东西，关于我们的 programming 就是 data type 和 input output。然后在session 2呢，就是在从11点到12点半下午，我们会给你们看这些some sample programs， 就是讲我们会 show 给你们看一些 examples。怎样去写那个 program 来 handle 那个 problem。 Okay, so welcome to the session 1. So 在这个 session 1， 我们we are going to look at the following items. Okay, the overview of computers. Okay, introduction to programming, basic concepts of programming, consisting of the data type and also the input output. So the overview of computers. Now, as you can see in this slide here, okay, computers started way back in the year 1950s, okay, up to until in the year 2020s, okay. You can see the size of the computer, okay, it changes from such a huge computer, you know, occupying basically it occupies the whole room. So you can see this is actually the whole computer room, and you can see the computer at the back. All right, so you have the programmer, all right, to control the computers. So it actually takes up the one whole huge room, and it requires special air conditioning for the room because it produces a lot of heat, the computer at that time. Then as you can see, it slowly progressed until the 80s, right? Then that's where, okay, for me, I myself, I start to experience, start to make use of this computer, personal, they call this personal computers, PCs, all right? So the size is no longer so huge. So everyone, users, normal users, we are able to own these so-called personal computers. And we can see here, but at that time the screen, we do not have the color screen yet. At that time, some of the monitors, you can have a green color. You can see the characters here, green. Very small size of the hard disk. Until today, you can see the size of the hard disk is one tera or 2 terabytes of hard disk space. So it slowly progressed until today. You can see we are using mobile phones. Okay, so even our mobile phones, it has gone through changes. You can see this mobile phone over here. We can even flip. We can even flip it. You can see the screen here. We can even flip into half, right? So that's the progression of computers. But as you can see, all those the computers, right? Whether it's whichever type of computers that you are using, the main thing is that the operating system. Okay, so operating system is required for every single computer because it manages the software and the hardware of the computer. Okay, so that's the purpose of the operating system. So if your computer don't have an operating system, basically it's actually useless. It's just basically a piece of hardware that can't do anything, you know, it can't perform anything, right? You can't even install program into your computer because nothing controls it. So you can see that is, you can imagine operating system as a middleman like that, in which it controls the hardware and also the software. So it coordinates Okay, in other words, the operating system coordinates all the running programs to make sure that the program they are able to access to the computer's hardware, such as the central processing unit, the CPU. Okay, so the CPU is actually the brain of the computer. Okay, it's like a brain. Because why is it like a brain? Because everything has to go through the CPU. Okay, so the CPU will decide what to do. All right, what can be done and what cannot be done. All right, the central processing unit. So it can distribute the job to the input devices or to the output devices. Okay, so it can process. So your central processing unit, it will process your input, the input that goes in to your computer. Okay, and then display out the output to those through the output devices, such as the monitor. Now, so there are various types of operating system in the market. We have Android, as you can see in this table here. We have Android, we have Windows, we have iOS, OS X, some unknown operating system, and also the Linux operating system. But if you look at the market share, right, at the moment, Android is still at the top of the market share, followed by Windows and iOS, yeah, for Apple. Your Apple phone, right? Your Apple phone, your iPhone, iOS. So what is a software? Software is actually a collection of instructions and data, okay, that tell the computer how to work. So basically, your hardware, your computer hardware, if you have only the operating system, is still of no use, right? Because you must have the software or the programs. So we have different types of software that serve different purposes. For example, you have a Microsoft Word. Okay, so Word is you can use Microsoft Word program to write documents, letters, yeah. But then you also have another program called Microsoft Excel, for example. So this Excel will perform a different task compared to Microsoft Word. Okay, so your Excel is actually a spreadsheet that allows you to do things like, for example, enter some data, okay, and then it can sum up your data. It can show you what's the sum of all the value that you have entered into the Excel. You can also use it to draw some graphs, right? Produce some charts. Okay. Then you can also have a software such as the games. Okay, so you can install the game programs into your computer so that you are able to play games. So there are different types of software. So basically, software is a collection of instructions and data that will tell the computer how to work. In computer science and software engineering, computer software is all information processed by computer system that includes your programs and data. Okay, so your programs and the data, these are your software. Okay, now so you can imagine that software. If you like the word software, right? It starts with a soft. It means something that if you can imagine that it's something that you cannot touch. Like for example, programs. We cannot touch the program, right? So that's why it's called software, right? We can use it, but there's no way for us to actually use our hand to touch the software or the programs. Unlike hardware. Hardware, on the other hand, like for example, your computer, your laptop, your mobile phones, these are hardware because you can actually touch them with your hand, right? Or your mouse, you can touch it with your hand. Okay, so that's the difference between hardware and the software. So software is a generic term used to refer to the applications. Like I mentioned to you just now, we have the Microsoft Word, Excel. Those are the applications. Yeah. Inside the applications, you can have scripts. Okay, scripts. There are some programs that can run in the application. Okay, so this program will the scripts or the programs will run on your hardware devices or your computer. Okay, so basically the instructions will be processed by the CPU, your central processing unit. Okay, so for the PC, these are some of the software for PCs, okay, and some of the software for the mobile devices. Can you all tell me or not what application are there? Okay, can you see this? Who knows what is this? Oh, this one. Okay, I'm sure all of you are more familiar, right? Are familiar with this logo here? Okay, 有谁可以跟我讲吗？这个是什么东西？这个代表什么 program？
Google
啊 ，Google Chrome， 对。这个一个 Fox 啊 ，Fox 说是 Mozilla Firefox， 这个是 Firefox 啊，但是我们比较少用了，对不对？我们比较多用就是这个 Google Chrome 啦，或者现在是 Microsoft Edge browser，Microsoft Edge。但是 Microsoft Edge 跟 Google Chrome 他们的 engine 啊，他们的 program 里面也是一样的，就是那个他们是用住那个 Chromium engine， 所以 Microsoft Edge 也是用一样的这个 Chromium engine。跟这个 Google Chrome 也是一样 ，OK， 所以我们这边有 Microsoft Word， 这个是Adobe Acrobat Reader， 那这个我自己不懂什么，我没有用好。
Steam
啊
，Steam，
哦 ，OK，Steam，Alright， 这个 mobile application 我们有 Facebook，OK， 这个 Twitter，Instagram， 这个是 WhatsApp 还是 WeChat？WhatsApp，OK， WhatsApp，Line。OK， Google Plus 这个这个我知道，这个是 YouTube， 这个我不知道，这个我不懂是什么。有谁这个你们懂吗？这是什么
？Snapchat。
哦 ，OK，Snapchat。OK， 所以你看在这个 screen 里面，我们可以看到 ，OK， 刚才我所讲的，我们有 hardware， 我们分作两种啊，对不对？hardware， 然后我们有 software。所以在这个我们用这个 hardware， 我们可以分出这个 input devices 跟 output devices。OK， 所以你看这边我们有 output devices，like for example 我们的 monitor 我们的 speaker。OK， 所以这个是 output devices。OK， 然后我们也是有 input devices，such as for example 我们的 keyboard， 我们的 mouse，gamepad，joystick。OK，microphone， 这个是 input devices， 所以我们用这个 input devices 来 enter 我们的 data，enter data， so enter data 就是那个 input 进去我们的电脑里面， so 我们的电脑 OK 有这个so our computer we have this Linux the operating system will obtain the we have this input subsystem to obtain the input from the user and send it okay give it to the CPU so that or the GPU so that they are able to process the input and produce the output to the various output devices. For example, the monitor. Okay, so for display, the output will go to the display monitor. Okay, for audio, then the output will go to the speaker or to the headphone. All right, so you can see this cycle here. Okay, next we'll look at the introduction to programming. So just now you have seen hardware and also software. All right, I mentioned to you about the operating system. Okay, that will coordinate between the programs and the and the CPU. Okay, so for these programs, okay, like for example, Microsoft Word, Excel, or games or some other application programs, you need to have a programming language. You need to use a programming language in order for you to develop those programs. Okay, so you can see that we have various type of programming languages. Just like for example, in our daily lives, right? We have languages. We have English, Chinese, Mandarin. We have Tamil. We have different type of languages. Same goes to the programming languages. We have different type of programming languages, such as for example, we have C++, we have Java, we have HTML, we have JavaScript, Python, and so on. Okay, many of them. We can't. I'm not able to mention all of them here, but they serve. But they basically serve the same purpose. That is to allow you to write the programs. Yeah. So in this competition, okay, in this this NSS competition, the programming language that you are going to use will be C++ and Java. So later on in session 2 today, we will show you the example programs written in C++ and Java. Okay, like for example, HTML, okay, is used to write web pages. So your web page, right? Your web applications that runs in the web server. You also have JavaScript. Okay, you can also use JavaScript to write that, or you can use Python. So, but okay, but for other programs, like for example, you can use a Java program or C++ program to write some desktop applications, which we'll see later on the examples in the session 2. So basically, a program is a set of instructions to direct the computer to perform certain tasks. Okay, so operating system is actually a program also, right? So your web browser, like for example, you see just now, your Mozilla Firefox, the Google Chrome, Microsoft Edge browser, they are also programs. Okay, video games, Adobe PDF, those are all the programs. In fact, just now you have seen the programs for PCs and also for mobile devices. So there are two types of languages. Okay, the programming languages. There are two types. You can categorize them as low-level programming languages or high-level programming languages. Basically, low-level programming languages. Okay, we don't use them. Okay, we don't write programs with using low-level programming languages. Like for example, one example of this low-level programming language is this assembly assembly programming language, because the assembly language is not so human readable. It doesn't really resemble our daily language. Okay, unlike high level programming language, it's more closer to the human language, like English, you know. So when we read them, at least we can still understand them. Yeah, we can still understand what they are trying to do somehow. But for low level language, like assembly language, it's more towards the machine language already. It's more, we can't really understand it unless you go and study and learn up how to code in this low level programming language. And the program will be very, very long because it deals directly with the hardware. Okay. The other one is the machine language. Then the one totally we don't have to bother already, because that is just in terms of 0 and 1s. Only the computer will be able to understand it, machine language. So what happens is that when you write your programs in higher level language, using high level language, after you compile the program, it will be converted into a machine readable form that is in 0 and 1s. That is the machine language. Okay, that is suitable to your computer hardware. So what we are interested is the high level programming language. Yeah. Then we have this syntax. Syntax basically refers to whether a statement is accepted by the programming language or not. It's just like, you see, our language, right? English, we have the syntax. You learn about the grammar. When you learn about the English language, you talk about grammar, right? So you must learn how to write or speak using the proper English language. Same thing to the programming. Okay, there's a syntax. So like for example, if you are talking about C++ programming language, then it has a set of syntax or rules that you need to follow when you write your program in C++. If you are writing your program in Java, then Java also has a set of syntax or rules that you need to follow, right? When you're writing programs, making use of the Java programming language. So it depends on which programming language that you are using to write your programs. You must learn their syntax. Okay, you must learn their programming syntax so that you're able to write the program that is acceptable by the compiler of that programming language. Then only the compiler of the programming language can convert your program, your high-level language program, into the corresponding machine code. And semantic it refers to the meaning of the instructions. Okay, so your instructions will have some meaning for the computer, so that your computer is able to perform the task that is that you want it to perform, as written in the program. Now in this slide, you can see here, you notice there's a bug here. Yeah, that's where this word bugs comes from. You see, bugs. So computer bug, when people talk about computer bug, it's not really this the bugs, okay, not this type of bugs, but basically we know that these bugs will actually destroy our things. Okay, if you have the bugs in your bed, right, then yeah, you destroy your beds, maybe you destroy the woods or things like that. So if you have bugs in your program, then your program will not be able to run correctly. All right, there will be problem. So therefore we have to remove the bug. That is what I call debugging. So debugging means basically you remove away the bugs to correct the problems. Okay, so if you have your computer program has bugs, you must identify what are the problems. Okay, what are the problems? Where is the bug? Where is the bug? So that you are able to correct it. So to correct the bugs, that's what I call debugging. Yeah, debugging, to identify the problems, isolate the source of the problem, and then correcting the problems. Or you determine another way to work around the problem, to solve the problem. Maybe this way of writing the program is not so suitable. You may want to change to a different way of writing it. Okay, using a different logic. So after you have debugged your program, you have to run the program to test the program again. Okay, to see whether you have successfully corrected the problem or not. Okay, so as to make sure that your program really works. Okay, next we look at algorithm. So what is an algorithm? Algorithm is a set of step-by-step procedures. Okay, it's a step-by-step procedures, or it is a set of rules to follow. Okay, for the computer to complete a specific task or to solve a particular problem. Okay, so in computer science, algorithm usually means small procedures that solves a recurrent problem. So algorithm is a well-defined computational procedures that will take some values, okay, which is your input, and then from the input, you will process the input to produce the output. Okay, so algorithm will process your input and produce the output for your computer. So you can say that it is a well-defined computational procedures, okay, that will process input into output. So the important criteria for algorithm is that it must be definite. So the instructions given must be clear. Okay, the instructions must be clear and unambiguous. Finiteness, it means that your algorithm must eventually stop. It cannot keep on running forever, you know. Then you get an infinite loop. Okay. So every programs, even when you write games, all right. So the program or the code inside, it has, even though it seems like to have some infinite loop inside, but then there's still a situation where you can actually terminate it. So every algorithm must be a finiteness. It cannot continue, go on and on and on and on non-stop. Effectiveness. So the steps are basic enough to be carried out. Okay, and the runtime speed must be proper. For example, Okay, when you look at algorithm, it's not necessary that you must think of algorithm is sure it deals with programming. No, it's not such a thing, right? So in our daily life, you can also think of the algorithm, right? For example, algorithm to fry an egg. Can you think of the algorithm to fry an egg? How to fry an egg? So we can actually come up with the algorithm, right? For us to fry an egg. So this is basically an instructions that people can follow, okay, when they want to fry an egg. For example, if I do not know how to fry an egg, but if you provide me with this set of instructions, and if your instruction is effective, where I can actually follow your instructions step by step, and your instruction is unambiguous, I will be able to fry an egg by carefully following your instructions. So as you can see here, the instructions to fry an egg: heat a frying pan for 5 minutes, pour some oil, crack the egg into the pan. Yeah, so you can see this step by step, very clear. Now, first step, I know I have to heat the frying pan for 5 minutes. So I'll do that. I'll follow the first step. And then after that, I'll pour some oil onto the frying pan. So that's the second step, right? And then in the third step, I will crack the egg into the pan. So it's not ambiguous at all. Step by step, I just need to follow them. Okay, one after another, one step after another. The first step, the second step, and the third step. Then the fourth step is, he asked me to wait 4 minutes. So while waiting for these 4 minutes, right, you can see here, there's a loop here, where I can continue to look at my watch, see is it 4 minutes or not. Oh, not yet 4 minutes, I still continue waiting. So here, I will continue to wait and wait and wait until eventually it reaches 4 minutes. So that is a loop, right? So you can imagine this as a loop here, where you continue to wait. Look at your watch. Okay, 1 minute already. Then wait. Look at your watch again. Hey, 2 minutes. Wait again, and then look at your watch again. Oh, 3 minutes, until eventually 4 minutes. So when it reaches 4 minutes, you go to the next step. In this step here, you start to think whether you want to have a medium yolk or you want to have a harder yolk. So you need to make a decision, right? You need to make a decision here. So if your decision is to have a medium yolk, then you proceed to cook the egg for 5 minutes. But otherwise, if you decided to have a harder yolk, then you'll cook it for 6 minutes. So you have to make a decision. All right. Then only it will proceed. Then only you can know what you want to do, right? Based on your decision, right? Based on your decision. And then the next step will be to flip the egg. And finally, the final step, you can then serve the egg to your customers. Okay. So this is the algorithm to fry an egg. Now, how about in computer program? So for your computer program, the algorithm. So here we have, let's say I want to write a program to allow me to swap two numbers. Now you imagine this, X and Y. Let's say you imagine X is a box. Okay, you have one box. The box you label it as X. You have another box. Okay, you have another box. You label that box with Y. So we can easily differentiate between these two boxes, right? We have one box labeled as X, another box labeled as Y. Inside the box that is labeled as X, we have the value 1. Okay, and then inside the box with the label Y, we have the value 2. But then you want to swap them so that the value 2 will be taken out from the Y and put into X, and the value in the box label in X, which is the 1, we are going to take it out, put into the box label as Y. Okay, so you can see here, take the 1 out, put into Y, and from the Y we take the 2 out and put it into X. So that's we are doing a swap. But how can we do this swap? Now you cannot simply just assign the value in the variable y to x, because this will override. It will override for other things. Let's say you imagine it's a house, right? Let's say it's a house. You cannot take someone from another house and simply dump into the you cannot take someone from the house labeled as y and dump it into x, because x got an occupant inside already. So the occupant inside the x, which is the 1, right? You take it out, put into somewhere else. You have to put it into another temporary house. Let this 1 stay inside a temporary house. And then the occupant inside the y, you can take them out, bring them to the house x. After you have bring the occupant from the house y to house x, then you can then take the occupant staying inside the temporary house, take them and put into y. So this is the algorithm, right? So we know this is the algorithm. So by knowing this algorithm, you are able to produce this piece of program called a swap. You give this program a name, you call it swap. So the purpose of this swap program is for us to swap the two numbers. Now let us see how this thing works first. All right, let's see this. So you can see here, this is like one house, this is another house. In this house, you have one occupant, the occupant is 1. In this house, you have an occupant inside, the occupant is 2. So this house is labeled as X, and this house is labeled as Y. Then you need to have a temporary house. Okay, so this temporary house that you label as temp. Then you're able to get the occupant out from the first house, put it into the temporary house. Okay. Then after that, in step 2, you are able to get, now you are in step 2, you are able to take the occupant in the house Y, take it out and put it into the house X. So now your house X, you have the value 2. Then in step 3, you are able to get the occupant in this temporary house and put it into the house Y, so that your house Y will now have the value 1. And that is how we have completed our task of swapping the two values in X and in Y. So basically our program called the swap program, we have the variable here, X, that refers to the first house, and the variable Y that refers to the second house. So we can use the variable X to obtain the value in the variable X, and we can use this this one, %X and %Y. These are the parameters. Okay, these are the parameters. So we can use this to refer to the variable X, and we can use this to refer to the variable Y. So we can take the value from the variable X, put it into the variable temp, put it into the variable temp, and then we can take the value out from the variable Y and assign to the variable X. And then in the third step, we'll take the value out from the variable temp and assign to the variable Y. So we completed our task in swapping the two variables. Now, so if you are writing, so you can have the algorithm, right? The algorithm, but the algorithm is still a bit difficult to understand because it's basically it basically involves the wordings. Well, let me go back to the algorithm. You see, it's all wordings, right? So another way of representing it is to use pictures, because basically people always say, right, pictures represent 1,000 words. So that's why we have this flowchart. So instead of just wordings like what you see in the algorithm, we use flowcharts, diagrams to represent the algorithm. Okay, so it's not just, you can use these flowcharts not only in your programming, but you can also use it in the daily life, like frying the egg, like the example that we said just now. So like for example, in this example here, if the lamp doesn't work, then you decide. Okay, you make a decision. Okay, so is the lamp plugged in or not? So there's a decision making here. If your lamp is not plugged in, you plug in the lamp. If the lamp is plugged in, then you check again. You check whether the bulb burned out. If the bulb is burned out, then replace the bulb. If the bulb is not burned out, repair the lamp. So this then is so much easier, right, for us to understand this algorithm because it's very clear to us. It's in a picture form. But all these pictures, they have their own meaning. Okay, so we have to learn the meaning. Okay, when to use this symbol, when to use this symbol. All right. So we have to learn the meaning, right, of the various symbols being used. So basically, you can see this symbol here. This is the terminator. Okay, it represents the start or the end of the program module, and this will represent the process symbol that represents the processes that you are going to perform. This is your input output symbol. Okay, that deals with the input and output operations. These are decision symbols where whenever you need to make decision, you use this decision symbol, and this is the connector. Okay, to indicate the entry or the exit of a program segment. Now let's look at this one here. So this rounded rectangle here, we have this this is your terminator symbol where it represents the start and the end of your program. So your starting and the ending of the program. So inside that, okay, after the start, then this symbol here, it represents input output. As you can see here, if you go back to here, you can see this one is representing the input output. So this is actually an output where you display the message. How many hours did you work? So you show to the user in the output device, for example, the monitor. So in the monitor, you show this message here. How many hours did you work? Then now you want to get some input from the user. You ask the user how many hours you work. You are now after that you will expect some input from the user. Okay, so this will be we are going to use this symbol here that represents the input. So the input will be for you to read the number of hours. So you get the hours from the user. So the user will input the number of hours worked into your computer system. That's why we use this symbol. And then we are going to display out some message. We are going to display out the message. How much do you get paid per hour? So this output. So once again, we are going to use this symbol for the output. And then after asking this message, you are expecting the user to input the pay rate. So this is an input. So read the pay rate. Now you have these two input already. You know how many hours the user worked. You know what is the pay rate for that user. You are able to calculate the gross pay, in which you know that the gross pay is the number of hours worked multiplied by the pay rate. So you use this symbol here, which is the process symbol. So this process symbol, you will multiply the hours worked with the pay rate. So you get the result. You can store the result in a variable. So your variable is called gross pay. Okay, the variable is like just now, as I showed to you just now. You can imagine it. It's like a box, or you can imagine like a house. Okay, where you can keep things inside, and you give it a label. So in this case, our variable here, we label it as gross pay. So after doing the computation, after calculating hours multiplied by the pay rate, the result of the multiplication, we keep it inside the variable gross pay. Then we can display out the value inside the variable gross pay. So this is the output, in which you display to the monitor, you display on the monitor what is the value of gross pay. And that's the end of the program. You use the terminal and end the program. So you represent your program or your algorithm with this flow chart. Okay, with the flow chart. So basically, when you use flowchart, anyone is able to understand. You make it easy for people to understand the flow of your programs, okay, the algorithm of the program, because this is just a normal language, human language that we use. Okay, so anyone is able to understand. The only thing is that they must understand what is the meaning of the symbol. Okay, so to understand the meaning of the symbol, we don't have so many symbols, so just some symbols here. So you just need to understand what is the meaning of the symbols, and you're able to use them easily, and people can also understand it. Okay, so for the input-output operations, this is represented by the parallelogram symbol, this type of symbol here, that will indicate the input or output operations, like for example, displaying some messages or getting some input from the users. And the rectangles, this is the process symbols where it's used to do some processing, like for example, arithmetic computations, like what you have seen just now. We actually compute for the gross pay. So this is a process, a mathematical computation. So we use the rectangle symbol. Now, apart from using the flowchart, you can also write pseudocode. So you see, before we actually write the computer program using a specific programming language, whether it's using C++ or using Java, we will come up with this, we will produce the flowchart. Or some people, they produce a pseudocode. So basically, the purpose of doing this is that we are actually writing out the instructions without having to know about, without involving the actual syntax of the programming language. So if you like the program flowchart and the pseudocode here, we actually don't care about the syntax of the programming language, because this is just a normal human language which anyone can understand. Our purpose is to convey the instructions to another user. So other users, when they look at the flowchart or when they look at this pseudocode, they can easily write the program using the programming languages that they want to use. For example, user 1 may want to use a C++ to write the program. User 2 may want to use Java to write the program. User 1 and user 2, both of them, when they look at your pseudocode or when they look at your program flowchart, they are able to use the programming language of their own choice. User 1 using C++, user 2 using Java to write out the program, okay, using the programming language of their choice. So when they write the program using the programming language, C++ or Java, then they must follow the syntax of the program. But when you design the program using the pseudocode or the flowchart, it is programming languages independent, because these are just human language. Okay, it resembles the human language. So you don't have to worry about the syntax of the program, the syntax of the programming language. Okay. So this is the pseudocode. Initialize the total to 0. Okay. Then you initialize the counter to 0. Input the first grade. Okay. Who is drawing the line? Can you all clear the line? Can someone clear? Who draws the line here? Can you all clear it?
For the admin, how to clear? Wait, I check for the admin can.
Thank you.
Press the view options and then press annotate and press clear
Wait,
on top.
Yeah, I can see it. Clear all drawing. Okay. All right. I've done it. Thank you.
Okay.
Okay, thank you. Okay, so the pseudocode here, as you can see, the pseudocode here, first we initialize total to 0. And then the next step, very clearly, we know that we have to initialize counter to 0. So this total, we know that is a variable, counter is a variable. Okay. Then we will ask the user to input the first grade. And then we have a loop here, this while. So while here, it means a loop. You continue to repeat. While the user has not yet entered the sentinel. Sentinel is some value that will eventually terminate the loop. You remember what we discussed just now regarding the your algorithm? Your algorithm must terminate somehow, right? You cannot have an algorithm that will have your program to run infinitely. Then you get an infinite loop. And therefore, if whenever you have a loop, like for example, you use a while here to create a loop, there must be a way that you can come out or exit from the while loop. So here in this technique, we are using the sentinel technique, where when the user enter a particular value known as the sentinel value, so it will terminate or exit from this while loop. Okay. Otherwise, the while loop will continue to repeat, in which it will add this grade into the running total, and then add 1 to the grade counter, input the next grade, possibly by the, and then then you ask the user to input the next grade. The user may enter a grade, or the user may enter a sentinel value. So if the user enters a sentinel value, this while loop will terminate. But if the user enter a grade, then the while loop will not terminate. It will continue, right? When it reaches the loop here, it will still continue. Okay, so here we get an input from the user. Okay, so then if the counter is not equal to 0, we will set the average to the total divided by the counter, and then we display out the average. Because you see here, we are performing a mathematical division here. We take the value from the total divided by the value inside the counter. We must make sure that the value inside counter cannot be 0, because mathematically we know that we cannot divide by 0, right? If you have anything divided by 0, that is a invalid result. You get an invalid result. Okay, so that is a runtime error. Therefore, you must do a checking. You can only do this. Okay, you can only calculate for the average if your counter is not equal to 0. If your counter is 0, then you cannot calculate the average. Then you will display the result. Otherwise, if your counter is 0, then you cannot calculate the average. You do something else. You can see here we make a division here. There's a division here we make. Is the counter equal to 0? If yes, we will do this. If the counter is not 0, we do the else. Else we do what? Print. We display no grades were entered. So you can see this whole thing, this whole piece of pseudocode here is very English-like human language. Okay, so basically anyone can understand it, the meaning of it. So what is a program made of? A program is made out of some common elements in the programming language, like for example, keywords. Okay, so keywords are some special words from the programming language that you're using. C++ has its own keywords. Java has its own set of keywords. That means it's a special words in that programming language that you cannot, that serve some purpose, that has some special meaning, and therefore you cannot simply use them. Okay, you cannot simply use them as you like. You must know what is served, what is the purpose of that keyword. What's the meaning, all right? What it serves. But you also have some programmer-defined identifiers. Identifiers, sometimes you call it variables, okay? You can call it variables, you can call it identifiers. So programmer-defined identifiers is you define the variables, you define the label. Yeah, it's like a label, like just now I tell you, right? X, this is I tell you the label X. Yeah. So you can define, like for example, average pay, or you can define a variable and identifier. You call it gross pay. So that is a user-defined identifier. It's defined by you. Now, one thing that I learned from my teacher, from my lecturer, long time ago, when I was studying, okay, for my degree, right? My lecturer always reminded us to always use meaningful names for your identifier names. When you define your own identifiers, always make use of meaningful name. Like just now, you say gross pay. Yeah, gross pay is meaningful. Yeah, so that is a good choice of a identifier name to be used. But if you define as GP, is GP a meaningful name or not to represent the gross pay? No, it's not. Who can understand what is GP all about? Who knows what is GP? Maybe you, as the programmer, when you define GP, you yourself, you know what is GP, but no one else will know that. But if you call it gross pay, if you call the identifier as gross pay, then it has a meaning. It's a meaningful name, and therefore it's easily understood by anyone. Then we also have operators, mathematical operators like the plus, minus, multiply, divide, and so on, punctuations, and finally the syntax. Okay, the syntax of your program. So keywords, we have these are the reserved words, or the reserved words in other words. It's a reserved words, like for example, int, float, double, char, const, void, and return. I will let you all know the meaning for each of these reserved words later on when we continue with our presentations. So you cannot simply use them, okay? Just remember, first thing when you talk about the programming language is to find out what are the reserved words for that programming language, so that you don't simply go and use them. Okay, so identifiers, make sure that it is meaningful. Now you have the rules as well. For example, if you are talking about, if you are using C++, you have to follow the C++ rules when you define your user-defined identifiers. So even though it's a meaningful names, but you still have to follow the rules. Like for example, gross pay. When you use the word gross pay as your identifiers, right? Gross pay. So it says gross pay. Yeah. Yeah, this is a good choice of the identifier name. But can you say like that? Gross pay? Cannot. You cannot, because it violates the rules, the C++ rules or your Java rules. They say that our identifier names cannot have a space between them. All right. So it can be made up of only letters, digits, and under underscore. No other symbols are permitted. So this is a space symbol inside in between them. This symbol is not permitted. Like that is correct. So you can give this as the identifier name, gross pay. This is a good one. Okay. But if you say your identifier name, you call it GP. No, this is a bad identifier name. No one knows what is that. All right. Illegal identifiers. Okay, here we show to you some of the examples of illegal identifiers. Employee salary. Why is it illegal? There's a space between them, between the two words. Why is this illegal? There's an exclamation mark. Why is this illegal? There's a plus symbol. Why is this illegal? Starts with a number. So therefore, when you start learning a programming language, whether it's C++, it's a Java or JavaScript, learn about the rules. Okay, how do you define, when you define identifiers, how can you define them? the rules. Okay, so that you don't use illegal identifiers in your program. Otherwise, when you try to compile your program, you get syntax error. You see the word syntax error. Just now in one of the slides earlier, we did mention about syntax. Yeah, syntax error. That means you are not following the rules or the syntax of the programming language. No, but syntax error is still fine. If you get syntax error, I'm quite happy to get syntax error also. I don't mind, because sometimes I can learn from the syntax errors that I obtain. And also it's not difficult. It's not so difficult to correct it. There's another type of error known as the runtime error. So when you compile your program, there's no error. Everything is fine. You get the machine code, and then you install into your computer and you run it. That is where after you run it, you get some problems. That will be a bit headache. That's what I call runtime error. Runtime error, because when you run the program, then only you encounter the error. Okay, so okay, next we continue. We look at the input, process, and output. These three things, basically, these are the foundation, the basis of our programming. When we produce a program, what we want to achieve is these three things only. No matter what program it is, whether it's a game that you're writing, whether it's a Word applications, Excel that you have used, all these type of applications or games, basically they want to achieve these three things: the input, the process, and the output. Every program must get some input from the user, right? Then the program must do some processing to get some result. After getting the result, it must display the result to the output. That is your output. So it involves only three basic things, nothing more than that: input, process, output, input, process, output. Okay, then how to get the input from the user? You can get it from a keyboard, you can get it from the files. Okay, you can get it from the mouse. These are the input devices. So get the input data from your input devices. Just now in the very beginning, we talked about the input devices. Then how about your output? You get after you process, you get the result, and now you want to output to the user. You can output it to a monitor, you can output it to a printer, right? You can output it to a hard disk. Okay, so these are the output devices. Of course, printer, monitor, these are output devices. Some of the device, they are input output. That means it can be used as input or output. Like for example, your disk. A disk can be an input device. It can also be an output device. Okay, arithmetic operations. These are processing. So in your processing, you will perform. You can perform arithmetic operations. You can do a logic. Perform some logic operations, or you can perform some operations. Your processing, like for example, arithmetic operations, you do some mathematical computations, right? Logic, you do some, for example, reasoning. If the traffic light is red, I do something, I stop my car. If the traffic light is green, I press on my pedal. So there is a logic. Yeah, this is a logic. You check for the condition, like the example that I mentioned to you regarding the traffic light. The condition that you're checking is the color of the traffic light. Is it red or is it green? Iteration means repeat. So you continue to do something, the same thing, again and again. So there's a repeat sequence of operations. Now, in the year 1960, the computer scientists already proved that your program actually requires only these three basic control structures. That is also known as constructs, which is sequence, selection, and repetition. These three things. By knowing these three things, you are able to produce any programs. Just three things only. Now, sequence. In fact, just now you have already experienced all these three things just now in the earlier slides. Remember just now, frying the egg, the algorithm to fry an egg. Remember what I mentioned? I mentioned step 1, I do this. Heat up the pan. Step 2, pour oil onto the pan. Step 3, heat the pan for 5 minutes. Now, I tell you step 1, step 2, step 3. There is a sequence here. There's a proper sequence, right? I must do step 1 before I can do step 2. I have to perform step 2 first before I can perform step 3. So there is a sequential order. And every program must have sequence. In fact, it's a simplest control structure. Okay, so you do one step after another step in a sequential order. Then you come to selection, where you select. Okay, you have to make a decision. Like just now example, when you come to the traffic light, you make a decision, a selection, whether you want to press on the pedal or you want to press on the brake. That depends on the color of the traffic light. Is it red or is it green? Next is the repetition. Repetition means you continue to repeat, to do the same thing again and again and again until you reach a condition where it will come out from the repetition. Now, repetition, you must always be able to come out from the repetition. If you are not able to come out from the repetition, you keep on repeating and repeating and repeating, imagine what will happen. Your computer will hang. And that is why sometimes you use your computer, right? Sometimes you encounter this, hey, suddenly my program hang already. I cannot do anything. Nothing works. I press any key also cannot work. Because the program inside there keep on repeating non-stop. There is an infinite loop in the program. So therefore, this will make your computer to continue to do some processing. When it keep on repeating, it just keep on doing the processing, cannot stop. And therefore, when you press any key also, there's no interaction. It cannot respond to your input. Because it's too busy. Your computer, the CPU is too busy processing the infinite loop already. And therefore, be careful. Remember, you need to have a stop condition. Okay? To represent a sequence structure in a flow chart, you can see here there's an arrow. You see the arrow coming down? This is a sequence. Okay? Do this, then this, then this. So step by step. Then to represent decision in a flow chart, you use this symbol. All right. So you make a decision. Is it the marks greater than 50? If yes, you do something. If no, you do some other things. Repetition. Now, repetition also you use this because you have to do some decision here, where you decide if X is less than Y. If yes, then you do this processing here, and then you repeat. You see, you repeat back to here again, and you to the decision here. So you every time repeat the loop, until this condition here is not met, or in another word, until your X is not less than Y. Then you exit. You don't repeat anymore. You come out. So you continue to loop, repeat until eventually your X is no longer less than Y. You exit. You come out from the loop. Okay. Okay, next section we talk about basic concepts of programming. Now look at the basic structure of your programming. Here we give you the example, demonstrate to you a C++ program and a Java program. Okay, they look very similar. That's why programming language, even though there are so many programming languages, it doesn't matter because they are quite similar. Okay, so basically, can you all tell me what will this program do? What will the program do? These two programs do. One is in C++, the other is in Java. Who can tell me? What will the program do?
Voice swap.
Sorry?
Void swap.
No, it's not swap. Basically, you can see here we have the A and the B, the variable A and the variable B, right? The value in the variable A is 10. The value in the variable B is 20. So we want to find out which one is bigger. Is A bigger? Is the value inside A bigger than the value inside B? Or B is bigger than the value inside A. We want to get the largest value among them. So basically, this program will compare the value in A and the value in B, and then it will output. Okay, it will return the largest among them. If A is larger than B, it return A. But if B is larger than A, it return for you B. That means you look at the value in the variable A and in variable B, and the result return is the largest among the two values. So in this case here, 20 is the larger one, right? It will return 20. So the value 20 is assigned to the variable C. So C will have the value 20. And then you use the Cout here to display the result in the monitor. Now you can see here we have a sequence. Just now I talked to you about the sequence. So when you do the program, it goes in sequence step by step. Perform the first line, second line, third line, and then finish. You see, in a sequence order. All right, sequentially. Now in Java, you can see Java also the same. You see here we have A given the value 10, B given the value 20, and then this function here, max function, is for us to determine whether which one is larger. Is the value in A larger than the value in B? And it returns for you the larger value among them. So in this case here, 20 is larger, so it returns for you 20. And the value 20 is assigned to the variable C, and then we use the system.out.println to display out the result to the monitor. So we have our process, okay? We have the input, we have the process, and we have the output, right? So you can see the input, process, output. The input basically is we get the input from the variables A and the variable B. Input into this the function that will determine which value among them is larger. Now, so you can see the difference, the slight difference in the syntax. Like for example, in C++, we talk about Cout, but in Java, we talk about system.out.println. Basically, it serves the purpose of displaying it to the monitor. Cout, display to the monitor. In Java, it is system.out.println to display to the monitor. Right? So you can see some differences. Like in C++, we have an INP main, but in C++, we use public class test, and then inside the class test, we have public static void main. And then the include files and the namespace in C++, but then in Java we use import to include the include files, right? The necessary files. Okay, just now this one we just give you a brief idea, you know, how the program looks like. We will discuss this in more detail later. All right, so data types. Now you can see here variables. Okay, so variables. You can see here A and B. It's not, I keep on mentioning A is a variable, B is a variable, C is a variable. So those are the variables. So variables are given a name. So that is your identifier lah. It's not I talk about identifiers. You must give a meaningful name. Remember this meaningful name? So always remember the word here, meaningful names for your variable names. Must give it a meaningful names, okay? You see, I remember this for so many years already, since my lecturer told me. My lecturer always tell me meaningful names, meaningful names. Yeah, I can remember until today. So C++ and Java is a strongly typed programming language. Now, when we talk about strongly typed, it means that you must tell, when you declare a variable, when you create a variable, you must mention what data can that variable, what type of data can that variable store? What type of data can the variable keep? Like for example, when I declare the variable A, the data that I can keep inside A, the value that I can assign to the variable A must be an integer value because the data type is int. Int is integer. Okay, so that is the data type. So for C++ and Java, it is a strongly typed language, meaning that you must declare the data type of the variable before when you declare them. So data type is actually a particular kind of data item that that represents the values that you can assign to the variable, the type of values that you can assign to the variable. Like just now I said int means you can only assign integer. Integer means it can be 0, it can be 1, 2, 3, 4, 5, the positive integer numbers, or it can be -1, -2, -3, -4. Those are negative integer numbers. Yeah, those are the integer values. Right. So okay, so there are data type. You can also categorize them into two categories. One is the primitive data type. Primitive data type, they are the built-in data types already defined by the programming language, the data type. Like for example, int is a primitive data type, right? But sometimes you can also have a non-primitive data type that is you can define the data type yourself. That means it's a more complex or user-defined data type. Okay. Now these are the primitive data types. You can see the word here, primitive data type. Integer is a primitive data type. Is the keyword just now you see we use int, okay, to represent the primitive data type. Floating point is a primitive data type. With the keyword you use float. Okay, for double floating point you use double. Boolean you use bool in C++ or boolean in Java. Character use char. Now string is not a primitive data type. Okay. So string, yeah, the keyword is string, small s, string in C++ and the capital S it is in Java. So the size of the variable, that means how much storage space it requires. Yeah, if you define an integer type, you will take up 4 bytes, meaning that when you store the integer, your integer value, it can be a range, it can range from this number to this number here, because it's 4 bytes. Yeah, so you can store the numbers ranging from this number until here. For floating point, 4 bytes, you can store fractional numbers. That means numbers with decimal points, so sufficient for storing 6 to 7 decimal digits. And then a double floating point, you can store up to 15 decimal digits. Boolean in C++ is 1 byte. It takes up 1 byte of the memory space, but in Java is unknown. So it stores the value true or false. Even though it stores true or false values, but in C++ it still take up 1 byte. But it's not known in Java how many storage space is actually taken up. In character is 1 byte in C++, the char type. In Java, it takes up 2 bytes. Okay, so 2 bytes is good for Unicode characters. That means if you want to store Chinese characters or Arabic characters, 1 byte is not sufficient to store them. You will need to have 2 bytes. String, basically, string, this is not primitive. It's actually the number of characters in the string that will determine the size of the string type. Okay, so example in C++ and in Java, how you define them for integer. If you define a variable, this identifier, my num is the identifier name. You define this as an integer type, so you can assign integer value. All right. For floating point, this is how you do it. You say float, so the data type is float, and the identifier name is my float num, so you can assign a floating point number, a decimal, a number with decimal place to the variable. Okay, double, boolean, char, and string. So string, for char, you can see the difference. Char is that single character, okay, not more than that. Because your data type is a char data type, you only can have a single character, and the single character must be enclosed in single quote, single quotation. Whereas for string, you use double quote. Okay, so the characters are enclosed in double quotes. are enclosed in double quotes. Okay, and this is how you do it for Java. For floating point number, you remember to put an F behind so that it knows that this is a floating point number. For double, then you don't put anything behind, just a number. 12.67, this is a double. Input output. So the input is the information that you supply to the computer or the program, and output is the information that is produced by your computer or your program. For example, to produce the output, okay, in C++, you make use of the cout keyword, cout. So the command is cout. Okay, you have to start with this std : cout. But if you think that it's very troublesome to always write std : cout, you can also just write cout without the std : without, you see, just write that cout. Don't need to put the std : also can. Okay, but later on I'll show to you, if you want to just write the cout without writing this std in the beginning of the program, you must start with a namespace. Okay, after I'll show to you. Then endl command is to give a next line character, a new line character, meaning that you see here. Now here when we do a cout, we output the word hello. Okay, then we do a cout to output the word world. When it appears in your monitor, it appears a single line. But why is it appears in the second example here? Why is it appears in two different lines? It's because your cout here, you also says cout end line. That means you are showing a new line character. Behind here, there is a hidden character that we cannot see, invisible character. That invisible character behind here, that is your end line character. The end line character. It means new line. That is why the word, when you display the word world, the word world appears in the new line, because there's a new line character here. So in the new line, you display the word world. Okay, in Java, you use the print function or print line or printf. Or what's the difference between them? Okay, if you use print, then you print whatever things that is inside the parentheses, inside the quotes. Okay, so it says print hello, right? So it's hello, then it says print world, then it's the world in the same line. But if you say print line, print ln hello, that means you print the word hello, and then you also print a invisible character behind here. That is the new line character, the invisible new line character. So that in the next line, when you do a print world, so in the next line, you see the word world in the next line. Now printf, f represent formatting, so you can perform some formatting. You can apply the format. Okay, for example, it says hello %s exclamation %n. Now this %s is the format, right? %n is the format. %s means it's a string. So the word this %s is like you put in some reserved place for this word. So you get hello world, because this world, the word world will go into this %s. So you see hello world exclamation, and then this %n is a new line character. Okay, it's a new line character. Converter. All right, so you can have these various type of converters. To convert for decimal place, you use D. Floating point, you use F. Okay, new line, you use N. So just now you have seen %n. For date and time conversion, you have all these. All right. Example. So the example here, you can see here in Java. This so the example here, it shows you how to use the %tc, right? %tc for it display out the it will produce for you this date and time format. If you're using TC, then this is the date and time format that it will produce for you. So you can see using printf to display out the value in the variables str. In the str, we have current date /time. So it display for you current date /time colon, and then the placeholder here, the formatting is %tc. So the value from the current date, the variable date has the value from the current date and time. So the current date and time, when you format it using %tc, It is Saturday, December 15, the time. Okay, MST. So this is the format that will produce for you. Okay. For further reference, you can refer to this link here. Formatting the output, you can also format the output based on the size, the position, and the number of digits. For example, here you can see here %d, %n for this n here. So the d is for the decimal number. So the digit. So it display you use %d for integer number. So you can see here it display 461012. So here we have a 08 with a leading 0. When you use 08, you have a 8D, that means 8 digit, 1, 2, 3, 4, 5, 6, 7, 8. You can see 8 digits, right? All together. But if your digit is less than 8 digit, then you have a leading 0, the 0 in front. So if you use a plus, that will include if the positive number, it will show you the plus symbol. Or if it's a negative symbol, it will show you the negative symbol. Comma include the local specific grouping characters. So if you have a comma, then for every 1,000, it will show you the comma symbol. Okay.
Professor Sun, after 1 minute we join back to the main room. Is it okay for you?
Okay. Well, after 1 minute, yeah. Thank you.
Thank you.
Okay. So this is an example program. Okay. You can see it yourself. And then this will be the output being displayed based on the sample program here. Yeah. And the stream manipulators, when you want to manipulate stream in C++, you use the IO_manic header file. You can use setW function to set the width. Okay, the width. Like for example, you also have the fix and set precision. When you use fix together with set precision, 4, it means you set it to 4 decimal place. Fix it at 4 decimal places. But if you just use set precision without the fix, then this is a 4 precision. You set it to 4 precision. You can see here 1, 2, 3, 4. Yeah, 4 precision. Okay. So example program. So input output in C++ and Java. Okay. In C++ you use cin for input. In Java you use scanner for the input. And then various input types in Java. If you want to read a Boolean value, you use next Boolean. If you want to read a byte, you use next byte, and so on. Yeah. So this is the example program in C++ and in Java, and the sample output that you will get in your computer. Okay. So that is all for this session 1 for this morning. I hope I will see you all later in the session 2. Okay, where I will show to you and explain to you in details some of the program examples. Thank you very much.
Thank you.